Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in this moon hopping series that I'm putting together. We're going to hop down from the outermost moon of Jupiter all the way down to Io, so we're going to go from Callisto to Ganymede to Europa to Io. And the reason I wanted to do this video series is because I wanted to show sort of an independent, sort of a solo flight example of a little bit about how to use IMFD. I learned a ton about using IMFD thanks to Dimitri's training that he did with me, not only in the videos that you guys saw, but also a bunch of time that he spent with me off camera where I was learning how to use IMFD. And I feel like I've got a pretty good handle on it now. So I think I can offer these explanations and go just into a bunch of detail and provide this sort of guide that I'm creating as we're doing this video series. I'm writing notes, and I'm going to make those notes available. I'll put the link in the description down below. Now, the nice thing about this trip from these different moons is that this plan is not only valid for trips between the moons of Jupiter, but it's also valid between the trips between the moons of Saturn, Uranus, and you could even do this very similar, if not exact same process to go from Earth to Mars. And if you go back and look at the IMFD training that I did with Dimitri, going from Earth to Mars, this is I think this is exactly the same thing that we did. So it's very much worth learning this method so that you can do this. All right, let me go ahead and switch camera views here because once again, I forgot to do that. I recorded this like 6 minutes ago and I realized I didn't switch camera views, so now I'm starting over the recording on this part again. One of these days I'll get it right. All right, so we just did our eject burn. We're on our way to Ganymede now. And the question becomes, when do we do the mid-course corrections, or do we do mid-course corrections? I've already put a couple notes here in for this video because I already started recording it. So what I wrote was that, once the burn's complete and you're on your way to the target body, the best time to do, got a typo there, at least an extra word. The best time to do any mid-course corrections will depend on a few factors. But one factor is always going to be the PEA as shown in IMFD's map program. So before any MCCs are considered, you should be well away. I should kind of put that as a note, or sort of a bracketed note. Before any MCCs are considered, you should be well away from the starting body. And actually, let me do it this way. So like note, before any MCCs are considered, you should be well away from the starting body. So what I'm saying there is we don't really need to even think about MCCs right now because we're still right here by Callisto. There's no point in worrying about MCCs. So let's at least get away from Callisto before we think about it. Now, what I like to do is warp time forward at 100 or 1,000, whatever, until the HUD has kind of gone like that, to where we're retrograde from where we were. Then I'll kill rotate. And then I can warp time forward, at a faster amount, 1,000 or 10,000. Now, we did just get out of Callisto's strong SOI. If we look at, probably Orbit MFD be the way to go. If we look at Orbit MFD, we can see that, this just changed from green to reds, but we're still getting quite a bit of influence from Callisto. You can see it's 0.45. So let's go forward. Let's get far enough away from Callisto that we don't have to worry about its gravity. And you can see our PEA kind of wobbling all over the place. And that's, again, that's because Callisto still has a lot of influence on us. So let's go 10,000. Let's get well away from Callisto. All right, that's good enough. Now we're at the point where Callisto is kind of doesn't really have a ton of impact, even though we're still kind of close to it, though. I mean, you can see it's still right there. It's just that Jupiter's gravity is so intense that you'll still be relatively close to these other moons, and but you'll be away from them otherwise. Now let's reference Jupiter. It's can auto reference, and let's target. Actually, let's reference Jupiter and target Ganymede. Let's target where we're going. So we're here, and we're going to rendezvous somewhere over here. So again, when to do the mid-course correction now that we're away from Callisto? Do we want to do it now, or do we want to wait a while? Well, in this case, we probably still want to wait a while because we haven't really gone that far away from Callisto yet. And if we watch the PEA, we're going to notice that it's going to wobble in and out. Right now it's going up. And if we kind of just keep going forward, we're going to see that it's going to start going back down. And you don't want to do the mid-course correction when the PEA is at its highest point, because then you're going to do the most change, because you're changing it from its highest value down to whatever you want it to be. So now you can see it's topped out and it's going down. So what I want to watch is I want to watch the PEA and I want to watch my PET, because on the other hand, I don't want to get too close to Ganymede before I start making changes. If this is going down, but I end up right on top of Ganymede before I start making changes, it's going to cost me a lot. So the two things that we're watching here, we're watching where we're at in our orbit around Jupiter, getting over to our destination, and we're watching our PEA. So there's kind of a balance there. Now, I would say when we're halfway there, so maybe use that green line there just as an indicator. That'll be about the halfway point. So let's go there and just watch what's happening with the PEA. And it's still going down, so we're just going to keep going forward. Still going down. No need to do any changes, and it's going down. I'm going to pass that point because it's still going down. But again, what you might see is that it'll just keep going down. But again, if you get too close to the target, it's going to cost a lot more. So we want to make sure that we don't get in too close. Right now we're 153,000 seconds out. That's like a day and a half. And if we want to now, we're close enough, we can go ahead and just reference Ganymede. And the reason we might want to do that is so we can just kind of watch its gravitational influence. If this ever gets to 0.01 and we haven't done a mid-course correction yet, then we'd want to do a mid-course correction by that point at least. But again, we're going to warp time forward, watching our PEA. And it's kind of at this point now where it doesn't know what it wants to do. So I think I'm going to say this is a good time to do the mid-course correction. I don't really know that there's a way to figure it out mathematically, scientifically. It's kind of one of those intuition things and experience things. So let's see how to put this into our notes. What I wrote before was watch your PET to determine when you're halfway toward the destination body. You can also refer to orbit IMFD to help know when you're halfway there. And use that halfway point, and let me say use that halfway point as a way for determining the better time to do an MCC. If you get to the halfway point and see that your PEA is trending up, then you should do a correction. But if it's trending down when you get to the halfway point, then continue forward until at least until the PEA starts going back up. However, if you get too close to the destination body and your PEA is still not where you need it to need, you'll want to do an MCC even if the PEA is currently trending upward, because it will, let me see, because the closer you get to the target body, the more expensive the correction will be. So that's kind of a lot to say for one step, but you get the idea. While we're still this far out away from Ganymede, we can make corrections without costing a lot. But if we get right up on top of Ganymede, then even a 1,000 kilometer correction is going to be very, very expensive. So it doesn't matter if this shows that we're getting a lower and lower PEA as we're getting closer to Ganymede. If in fact we're getting so close to Ganymede that it's going to cost us a fortune to do that mid-course correction. We don't want that. Now, to do a mid-course correction, typically I like to be in the prograde position around whatever body I'm orbiting. So I'll go prograde, and I'm just going to use the inefficient method of pressing prograde and going to 10x. I would never do that if I was concerned about the delta velocity, but in this case I'm not. So now that that's off. And we can either set up the delta velocity program and see what impact it has on the IMFD's map program, similar to how we set up TransX maneuvers. But in this case, just like with TransX, we can just watch IMFD's map program and we can see if we can just do a mid-course correction without bothering to set up a maneuver first. Because usually, a lot of times you can make corrections in just with translation thrusters, and it'll only cost you 1 meter or 2 per second, and there's no need to go through the trouble of setting up a delta velocity maneuver. So let's see if we can do that. So go to translation, and I don't know which way to translate, so I'm just going to say what happens if I translate forward. That's not helping. You can see it put the PEA lower. But what happens if I translate, let's say, inward? That's helping. And probably inward and backwards is all I'm going to need. I don't imagine plane change will help in this case because we had an EIN of 0.00. But we can check. If I press up, 8, that's making it worse. A little bit of down is having a small impact. But basically, inward and a little bit of reverse. So I'm going to actually press and hold 1 and 9. And that's actually taking a little bit longer than I thought it would. I can do that, but it may not be the most efficient way to do it. So just for this first example, let's go ahead and set up a delta V maneuver just to see how, what the cost might be. So on this side, we're going to bring up the delta velocity program, and it's already shared. Actually, it's unshared. That's what I want. And this side should still be shared. It is. And we're going to turn on page over here. First of all, since this is still retaining its information from prior, we need to kind of set everything back to 0. So set 0, set 0, set 0. And we need to do this burn at some point in the future. So let's set this to say 240 seconds so that we've got 4 minutes to set up this burn. And our source is us, that's correct. And we're referencing Callisto, that's wrong. We're no longer referencing Callisto. We want to reference the Jupiter. Not the Jupiter, but we want to reference Jupiter. And it changed my TEJ for some reason, so let's set that back to 240. And over here in MapMFD, we're going to turn our plan on so we can see what impact this has on our projection, or on our path. And it defaults to 10. We can go with that and see what happens. And that's wrong, and actually we know that's wrong because it was helping if we went the other way. So let's go -10. And by going -10, we have a PEA closer to what we want. Let's do an adjustment. And something like, probably something like that, or even right all the way down to the surface. Maybe even a little bit below the surface still, because we don't really know which way it's trending. It looks like it's trending up. So maybe even a little bit below the surface would be good. So that would be 18.5 meters per second. So let's reset that for a second. And we also saw that inward-outward was helping. So let's see what happens if we do some inward instead of prograde. And that's going the wrong way. And yeah, we can see that that's not better. We're already at 22 meters per second. It's pretty close, but it would cost us a little bit more to do inward-outward. So we'll set that back to 0. And let's go back to the delta, the forward. And it was like -18, I believe. Yeah, something like that. And we're going to go with that. We're going to do that burn. So let's go to the page here. Auto burn. And since we're less than 180 seconds out, it's going to start orienting the vessel right away. So let's put that in a step. Let's think about that in terms of a step once this gets done orienting. Okay, so to set up a mid-course correction, it can often be better to just bump the translation thrusters one way or another using prograde, retrograde, lateral, or up-down translation. For small MCCs, it's not worth the time, trouble to set up a delta velocity maneuver. And you can't determine the size of the mid-CC just based on, how much your PEA is off by, because when you're really far away from Mars, a negative 1,000 PEA is nothing. Even negative 2,000 or 3,000 is nothing. But in this case, we're in a smaller system, so 1,000 or 2,000 meters per second, or rather 1,000 or 2,000 kilometers, is a bit more, and you can see it's costing us a bit more. But if we were going to Mars and we had a PEA that was off by 2,000 kilometers, it would only take a meter or two per second, when there would be no need to set this up. But again, the closer you are to an object, or the smaller the system, like here at Jupiter, it's, even though Jupiter is huge and its system is huge, it's small compared to the size of the solar system. So going from one moon of Jupiter to another is a much shorter trip than going from Earth to Mars. And in that case, and what we may want to do in the future, we may not want to set the PEA so low to begin with. So going from Ganymede to Europa, I'll keep that in mind, that we may not necessarily want to target the center of Europa like we did here. So again, let's go back to our notes here. So to set up an MCC, etc., for small MCCs, it's not worth setting the time trouble. Okay. For larger corrections, you will certainly want to set up a delta velocity maneuver so that you don't waste DV guessing which way to burn. Okay, now let me keep that in the step. To set up a delta velocity maneuver, bring the delta velocity program up in IMFD on the side that is not shared, and make sure you have IMFD's map program up on the side that is shared. Make sure you have IMFD's map program up on the other side, and make sure that it is shared with the delta velocity program. And this is all step 3. Now, in IMFD's map program, make sure you have the plan turned on so that you can see the changes in real time that you are making in the delta velocity program. Make in the delta velocity program, start by setting the TEJ to about 240 so that you have 4 minutes to set up the maneuver. Did I pause this? Yeah. The maneuver per the English spelling of maneuver. I know there's a lot of ways to spell it, like transx is like man-O-E-U-V-R or something, but I don't know how to spell it that way. So we have about 4 minutes until the maneuver. Then adjust the DVF to bring the PEA as seen in IMFD's map program down to a low number. If necessary, adjust the DVP and DVI as well, but try to get the correction with just dvf, I believe. Well, actually, I shouldn't say that. That's not true, because if it depends where you're at in your orbit. So yeah, let me not even say that. Let me just leave it at that. If necessary, adjust the DVP. Actually, let me not even say it that way, because that's not a good way to say it. So adjust the DVF to bring the PEA, as seen, down to a low number. In some cases, the DVF will cost more than it would to do the MCC with just DVI, or perhaps even just DVP. So you will have to experiment with the different velocity directions to determine the best one to use. This is important because if you set the PEA as seen in IMFD's map program to the surface with just DVF, but you don't check the cost with DVI, you may end up committing to a burn that is far more expensive than is necessary. All right, I think that's explained well enough. All right, let's unpause and commit to the burn. Go ahead and warp time forward to get over to the burn. Okay, once the maneuver, once the delta velocity maneuver is set up, press the PG button to reveal to get to the BV/AB page, and press AB to burn the maneuver. I spelled maneuver wrong again. Maneuver. And that's what we've done here, and that's where we're at. So let's warp time forward to go through the burn. Also, as we noted before, once we get close to the burn, we can actually turn the plan off, and then that way we'll see the result of our plan in real time as we do our burn. And you can see with just whatever that was, 18 meters per second. If we watch BV, we can see it's done. Then we are there where we set out to go, which is -66. So let's just put that note in there as well. Let me copy what I had before. Yeah, here, this step. Just to have that in there, just as a note. Which is just after you start the burn, or even a few seconds before the burn is started, shut off the plan. That way we can see the results. Now we have the results of that plan, so let's go ahead and go forward. Now, in a perfect world, we would be able to just now go all the way forward until we were within, Ganymede's weak SOI at least, and then that would be fine. But if necessary, we'll do another correction. We'll just continue doing what we did before. We'll use the PET and the PEA to help us determine if we need to do another mid-course correction. So in this will be a sort of a recycled step. All subsequent MCCs will be determined by the PET and PEA values as seen in IMFD's map program. Go forward in time until the PET value is half as much, and keep an eye on the PEA value. Perform any additional MCCs as necessary. And we're just going to have to leave that as a generic step because we don't know if we're going to have 2 mid-course corrections or 3 or 4 or 5 or whatever. Generally, you're not going to have more than 1 or 2, but So now we're going to watch our PET, and we would like to maybe cut that in half. But if the PEA starts getting erratic, then we're going to have to make note of that and do an MCC a little bit earlier. But let's just warp time forward and see what happens. See, the PEA is holding pretty well, so we'll probably be able to get to at least half of our current PET. Yeah, we will. And just notice how stable that's holding. So the idea here, now that we're halfway there, we can assume, and we're also within the weak SOI. Let's get a little bit farther out. Now, just using your intuition and understanding what's happening, since this is holding so stable at this point, and we've cut the distance in half, we can now bring the PEA up to the value that we want it to be, and it will probably hold at that altitude all the way until we get to our target. Now, in this case, I'm almost positive there's no need to set up a delta velocity maneuver, so let's go to linear translation and bump them around. Okay, so a little bit of forward translation from this angle is helping, and a little bit of down is helping. Again, if we want, we can go prograde to the reference body, and I tend to like to do that. That way I just kind of know for sure what direction I'm translating, because when you're off to the side and up and down, you don't really necessarily know what prograde is and what plane change is. Okay, so now a little bit of negative prograde, in other words, backwards, and a little bit of inward is helping. So I'm going to say at this point we can probably set the PEA to, like 10 kilometers. Again, Ganymede doesn't have an atmosphere, so there's no need to worry about getting into the atmosphere, but it is in such close proximity to Jupiter, and there are other significant moons around Jupiter that our PEA will probably oscillate as we orbit Ganymede. Now, one thing I completely forgot to take into consideration is the target base, and that's very unfortunate because we should have thought about that much sooner. So what we may do on this first flight is just kind of show up wherever we show up, and then on the next flights we'll have to remember to set a target base. I can also see, according to Orbit MFD, that I'm going to be retrograde, and that's pretty much in agreement with what I'm seeing here in Map MFD. But if I bring up Map MFD over here and reference Ganymede, I can get a better idea. Let's change the projection. I guess it doesn't matter. And here we can see that our EQI is 165, so that's retrograde, and it doesn't matter in this case, but if I had thought about it sooner, I would have made sure that we were prograde. More importantly, I want to see what the latitude and longitude are. I can see that it's 27 west and 12 north. So let's bring up Map MFD and reference Ganymede. It's already referenced. And our target base is here. Let's target it. Ganymede base. Ganymede base is at 72 west and 15 north. So we're going to be not too far off from the north, but our west position. Actually, I don't suppose our west position matters as much as the north position. So it's not going to be too bad. We got a little bit lucky on that. But in the future, I will make note of where we're going to end up at when we get to our target. You just want to think about that a little bit in advance so that you don't have this massive plane change to do once you get there. But before we get all the way over to Ganymede, we'll go ahead and do some kind of correction here for the base alignment. But we're almost at 30 minutes on this point of the video, so I'm going to stop it here, and we'll pick it up in the next part, do our base alignment, and then get over to Ganymede and land. Perhaps we'll do that in the next video. Maybe we'll have to split the landing up into yet another one. If you like this video, hit the like button. Don't like it, subscribe to the channel if you're not already subscribed so you can be notified when I upload new orbiter videos. Check the description down below for links, and I will see you in the next part. So before any MCCs are considered, you should be well away. Should kind of put that as a note, or sort of a bracketed note. Before any MCCs are considered, you should be well away from the starting body. And actually, let me do it this way. So like note, before any MCCs are considered, you should be well away from the starting body. So what I'm saying there is we don't really need to even think about MCCs right now because we're still right here by Callisto. There's no point in worrying about MCCs. So let's at least get away from Callisto before we think about it. Now what I like to do is warp time forward at 100 or 1,000, whatever, until the HUD has kind of gone like that, to where we're retrograde. Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in this moon hopping series that I'm putting together. We're going to hop down from the outermost moon of Jupiter all the way down to Io, so we're going to go from Callisto to Ganymede to Europa to Io. And the reason I wanted to do this video series is because I wanted to show sort of an independent, sort of a solo flight example of a little bit about how to use IMFD. I learned a ton about using IMFD thanks to Dimitri's training that he did with me, not only in the videos that you guys saw, but also a bunch of time that he spent with me off camera, where I was learning how to use IMFD. And I feel like I've got a pretty good handle on it now. So I think I can offer these explanations and go just into a bunch of detail and provide this sort of guide. This like 6 minutes ago, and I realized I didn't switch camera views, so now I'm starting over the recording on this part again. One of these days I'll get it right. All right, so we just did our eject burn. We're on our way to Ganymede now. And the question becomes, when do we do the mid-course corrections, or do we do mid-course corrections? I've already put a couple notes here in for this video because I already started recording it. So what I wrote was that, once the burn's complete and you're on your way to the target body, the best time to do, got a typo there, at least an extra word. The best time to do any mid-course corrections will depend on a few factors. But one factor is always going to be the PEA as shown in IMFD's map program that I'm creating as we're doing this video series. I'm writing notes, and I'm going to make those notes available. I'll put the link in the description down below. Now, the nice thing about this trip from these different moons is that this plan is not only valid for trips between the moons of Jupiter, but it's also valid between the trips between the moons of Saturn, Uranus, and you could even do this very similar, if not exact same process to go from Earth to Mars. And if you go back and look at the IMFD training that I did with Dimitri, going from Earth to Mars, this is, I think this is exactly the same thing that we did. So it's very much worth learning this method so that you can do this. All right, let me go ahead and switch camera views here because once again, I forgot to do that. I recorded from where we were. Then I'll kill rotate. And then I can warp time forward, at a faster amount, 1,000 or 10,000. Now, we did just get out of Callisto's strong SOI. If we look at, probably Orbit MFD be the way to go. If we look at Orbit MFD, we can see that, this just changed from green to reds, but we're still getting quite a bit of influence from Callisto. You can see it's 0.45. So let's go forward. Let's get far enough away from Callisto that we don't have to worry about its gravity. And you can see our PEA kind of wobbling all over the place. And that's because Callisto still has a lot of influence on us. So let's go 10,000. Let's get well away from Callisto.